After decades of searching the cosmos, the James Webb Telescope has finally uncovered something scientists and dreamers alike have long defined, and it changes everything. In the darkest corners of the universe, where the light of stars barely touches the surfaces of distant planets, lies a secret that scientists have pursued for generations. A question that has obsessed humanity ever since we first looked up at the sky. Are we alone? This timeless inquiry has guided scientific exploration, fueled philosophical debate, and inspired endless works of fiction. For centuries, our curiosity has been matched only by the vastness of space itself. Now, the James Webb Telescope, the most powerful and sophisticated machine ever constructed to explore the cosmos, has broken the silence of the universe. What it has detected is not simply an anomaly or a coincidence. It is something more. It is a signal, an indication so strong, so improbable, that it holds the potential to change everything we think we know. Stay with this journey until the end, for what you are about to discover could redefine the meaning of our existence and confirm what countless generations have only dared to hope for: the confirmation of life beyond Earth. This remarkable story begins with a planet known as K2-18b, situated approximately 124 light-years away from us, a relatively short distance when measured against the vast scale of the cosmos. In the atmosphere of this intriguing world, the James Webb Telescope's cutting-edge instruments have detected dimethyl sulfide, a compound that, on Earth, is solely produced by living organisms, particularly marine phytoplankton. The presence of this molecule is not only rare but chemically unstable, suggesting it must be continuously generated by some ongoing process. If that process is biological in nature, then what we are witnessing is not just a hint of life. It may be the discovery of an entire biosphere, an alien ocean world teeming with diverse life forms completely unlike anything found on Earth, yet equally dynamic and complex. This groundbreaking revelation has sent shockwaves through the scientific community, compelling experts to confront the possibility that humanity may not be alone in the universe. Understandably, the initial reaction from scientists was one of caution. A single detection does not constitute definitive proof. The dimethyl sulfide was recorded by just one of Webb's instruments, operating within the near-infrared range, a spectral region where similar gases, such as methane, could be misidentified. However, NASA did not rest on a single observation. On April 17, 2025, the telescope once again targeted K2-18b, this time using a different instrument that captured data in the mid-infrared range. This second observation confirmed the presence of dimethyl sulfide, and at concentrations nearly 10 times higher than those found on Earth. Such a finding strongly suggests a biological source that is active and ongoing. And if the compound breaks down rapidly, as it does on Earth, then something must be producing it continually right now. Everything points to K2-18b as being a planet of immense interest. Its density, orbital distance, and surface temperature suggest a water-rich world cloaked in a hydrogen-dense atmosphere, perhaps fully covered by a deep, alien ocean. Life could exist beneath these waters, adapted to conditions of high pressure and temperature. Such organisms may rely not on sunlight, but on chemosynthesis, much like life forms around Earth's hydrothermal vents. Picture glowing, bioluminescent creatures drifting through alien waters or massive, soft-bodied beings floating in the thick hydrogen clouds. Though it seems like science fiction, it is now part of one of the most serious scientific conversations of our time. What's even more incredible is the implication of such a discovery. If life can exist on K2-18b, so close to us in cosmic terms, then the likelihood of life being widespread throughout the universe dramatically increases. The statistical confidence in Webb's findings stands at 99.7%, not quite enough for a formal declaration of extraterrestrial life, which requires 99.9994% or the infamous 5 sigma threshold. But it is the closest humanity has ever come. While some scientists call for more validation, others are already proposing new missions, instruments, and telescopes that can focus solely on K2-18b and similar exoplanets. As this revelation spreads, it is not only science that is shaken. The social, cultural, and philosophical ramifications are enormous. Religious leaders are responding, people are speculating, artists are creating, and the internet is ablaze with theories and imagination. The James Webb Telescope, initially launched to study the first galaxies, has unexpectedly thrown open a door to a new era of discovery and possibly contact. And just when the global conversation began to stabilize, new data emerged. Rhythmic thermal fluctuations detected on K2-18b's surface. These emissions appear artificial in pattern, leading some scientists to cautiously speculate about non-natural sources, perhaps even intelligent design. While there is no consensus, and skeptics call it an error or anomaly, one thing is clear. We are peering through a window into a world that holds secrets deeper than we ever imagined. The James Webb Telescope is not merely showing us another planet. It has torn open a crack in the veil of the unknown, a crack that, once revealed, cannot be sealed again. We are standing at the edge of something profound, a turning point in human understanding, a quiet moment before the universe answers back. And so, the questions intensify. What kind of life could truly exist on K2-18b? Would it be microbial and simple, or multicellular and complex? Might it possess a unique biochemistry evolved in the planet's hydrogen-rich environment, perhaps based on silicon or ammonia instead of carbon? These considerations are no longer hypothetical musings, but serious scientific queries. Researchers are developing new models to simulate K2-18b's atmospheric dynamics, ocean composition, and potential biospheres. Some even suggest that its ecosystem could be older and more stable than Earth's, having evolved in isolation for billions of years, uninterrupted by mass extinction events like those that shaped our evolutionary history. If that's the case, K2-18b could harbor life forms with intelligence or organizational behavior, life that perhaps communicates, builds, or alters its environment in subtle ways we have yet to recognize. Meanwhile, international space agencies are beginning to collaborate in unprecedented ways, proposing long-term missions, advanced orbiters, and high-resolution spectral scanners capable of remotely detecting biosignatures and even technosignatures from planets like K2-18b. There is also growing public demand for transparency and timely updates. Governments, too, are being drawn into the discussion, not just from a scientific perspective, but from the angle of diplomacy, security, and planetary protection. If signs of intelligent life are eventually confirmed, humanity will face a psychological and cultural shift of unparalleled magnitude. As the world watches, united in awe and curiosity, one reality is clear. Our place in the cosmos is no longer a matter of philosophy or belief. It is a scientific frontier unfolding before our eyes. The James Webb Telescope has not merely extended our vision outward. It has turned the mirror back on ourselves, forcing us to ask what it truly means to be human in a universe that may be teeming with life. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. Thanks for watching, and we'll see you in the next.